Hello everyone, welcome to our YouTube channel. Don't forget to hit the subscribe button and like our channel. My name is Anita and I'll be taking you through production planning and control. We shall begin with the introduction. Production is the process of combining various material inputs and immaterial inputs in order to make an output. So production basically is the process of combining the raw materials, the equipment, human labor in order to make an output. Then what is planning? Planning is a process of deciding in detail how to do something before you actually start to do it. Before you proceed with the production process, you need to first make a plan, know how you're going to produce your products. Then what is control? Control is the ability to keep within bounds. Your production has to be controlled to maximize efficiency. Now, after knowing all that, you can now define production planning and control. This is a work process that seeks to allocate human resources, raw materials, and equipment in a way that optimizes efficiency. So once your production is controlled, once you have made a plan for your production, you will definitely optimize efficiency. So the production planning and control provides a series of objectives and decisions pertaining to what product or service to provide, how much to produce, and in what quantities, with what resources, when, and in what sequences to produce. Once you do production planning and control, you will get that information. You will be helped in making decisions on what to produce, how much to produce, in what sequences, when to produce, and that will help you optimize efficiency in your production. Then let's go to uncertainties under which production planning works. So the first uncertainty in production planning, there is the uncertainty involved in context and magnitude of external factors. What are these external factors you're talking about? We have customer demand, bids, contracts. In this case, the customer demands may change due to changes in tastes and preferences, changes in seasons. So that will be the uncertainty during your production planning, since you had not planned for it. Then we have errors in the assessment of required resources of the product system. What are these resources we need in our product system? For example, the financial funds, the equipment capacities, workforce capacities. So during your production process, you may have inadequate funds, and that is the uncertainty when you're doing your production planning. Now we got production planning and control function. What is the function of production planning and control in your business? Production planning and control presupposes the availability of adequate information on all internal and external aspects related to production. For example, information on quantities being produced. Once you do production planning and control, you will definitely know how much to produce. Since in plan, we said planning helps you know how you're going to produce or how much you're going to produce. Then you have kinds and quantities of materials needed. What materials do you need? Once you do production planning and control, you'll be able to know the kinds and quantities of materials you need for your process. Then we have sources of materials. Of course, once you know the materials you need, you will find out their sources, and that is done during production planning and control. Then also have skills and workforce capabilities required. Once you do production planning and control, you'll be able to know the skills of the labor you need for your production process. So we can go to requirement planning concept. What are major sources of information inputs in planning concept? We have bill of materials, master production schedule, and inventory records file. Let's look at the bill of materials, what we call BOM. So the bill of materials is the listing of all raw materials, components, sub-assemblies, and assemblies required to produce one unit of a specific finished product. So before you start your production, you need to know what raw materials you need, the assemblies, the components, and the assemblies, because we know the finished product or the final product is got from the raw materials, components, sub-assemblies, and assemblies. So the BOM, or the bill of materials, helps you. It provides you with a description of how a finished product is made from raw materials, part assemblies, and assemblies, as we shall see in the example below. So here is our example. They have said XYZ company produces skateboards, and each skateboard is assembled by the combination of 3 sub-assemblies. Board, we have 1 unit per skateboard, axles 2 units per skateboard, and wheels 4 units per skateboard. Then you're asked to prepare a BOM for the skateboards. This is how you prepare your bill of materials. You put the name of the company, which is XYZ company. You put the name of the document. Our document is the bill of materials, so we put bill of materials. Then now we have part code, assembly name, and quantity per unit. What do we need? Why do we need part codes? For easy identification. So for boards, we can decide to have ABO as the part code of boards. Then AAX for axles and AWH for wheels. Then we said for boards we want 1 unit per skateboard. So the quantity per unit will be 1. The axles 2 units per skateboard. That means the quantity per unit will be 2 units. Then the axles, the wheels, we need 4 units per skateboard. So that's how our bill of materials will look like. Now we go to demand dependency. These are terms we need to know in production planning and control. What is demand dependency? Demand dependency is where the demand of the product is derived from or is related to the demand for another inventory product or item. Demand dependency, because as we said, the final product is got from the raw materials, the components, and assemblies. That means the demand for the components is derived from the demand for the finished product. That's what we call demand dependency in production. Then we have product file structure. What is a product file structure? This shows the relationship between components and assemblies essential to correct development of requirements. These are level relationships and the item. These are level relationships which state that all assemblies are considered to be a parent item and the items that make up the assembly are component items. Let's have the graphical representation for more clarity. We say they are level relationships. So we have the level 0, level 1, level 2. We can add on level 3 depending on the product we are producing. So in level 0 we have the assembly or the final product. Then we have level 1, which has the component items. These are the items we shall use while making the assembly. Then we go for level 2, which has raw materials. We need raw materials for us to come up with the component items. So that's the flow. All those are the level relationships shown by the product file structure. Let's go to forecasting requirements. What is sales forecasting? Sales forecasting is the estimate of the level of demand to be expected for a product for some period of time in future. Forecasting, you may depend on the current demand of your product to estimate its level of demand in maybe 5 years to come, 10 years to come, for some period in future. Then we have different types of forecasting. We have long-term forecasting and short-term forecasting. For long-term forecasting, this is done for a considerable period of time, for example 10 years or even more. The example I can give on long-term forecasting is where I find the government puts a policy on the demand of a certain product. It says like in 20 years, after 20 years, the demand of umbrellas will increase this percentage. So that is long-term forecasting. Then for short-term forecasting, it is the forecasting for relatively shorter periods of time. Might be a week, a month, a year, depending on the type of a product. So for short-term forecasting is basically when it is the rainy season, the demand for umbrellas will be high, but then after the demand will go low. But after like one month, the rainy season will be back, so that the demand for umbrellas will go low. That is the short-term forecasting. You know that after 1 month or after 1 week, the demand for your product will increase or will reduce. We got forecasting methods. What are the methods used in forecasting? The first method is the simple moving average. What do you mean by simple moving average? In this method is used to forecast for consecutive periods when the demand for the forecast follows a horizontal pattern and doesn't have any seasonal characteristics. What do we mean consecutive periods of time? If we want to forecast for our product, the demand of our product in 10 weeks time, that means we shall consider from the first week till the 10th week. We are not skipping any week in the middle for consecutive periods following each other, and it does not have seasonal characteristics. This method generates the next period's forecast by averaging the actual demand for the past data and is used for short-term forecasting. Let's take a look at this example for more clarity. So we have an example for simple moving average where we are given the weeks. We have weeks, then we have actual demand. We have actual demand in units. Then the weeks we are given: week 10, week 11, week 12, week 13, week 14, week 15, and week 16. Then the actual demand for week 10 is 105, for week 11 is 110, week 12 107, week 13 is 118, week 14 is 120, week 15 is 101, and 106 for week 16. So we are given that in our question, but now they want us to use the 3-week moving average to forecast the demand of the item. 3-week moving average. So for us to get the forecast, we shall first get the cumulative demand for the past 3 weeks. So we add the column of cumulative demand for past 3 weeks. For past 3 weeks. Then what is the cumulative demand for past 3 weeks at week 10? We are not given the demand for week 9, week 8, and week 7, meaning for week 10 we don't have the cumulative demand for past 3 months. It will be that. Then also for week 11 we don't have the past 3 months, so it will also be like that. Week 12 we also don't have, will be the same thing. But for week 13 we are given demand for week 12, 11, and 10. So for week 13 our cumulative demand will be summing up the actual demand for week 12, 11, and 10, and it will give us 322. For week 14 we shall add the actual demand for 13, 12, and 11 since it is the cumulative demand for past 3 weeks. Hope you are together. Then we shall have 335. For week 15 we shall add for week 14, 13, and 12, and it will give us 345. Then we go for week For week 16, we shall add for week 15, 14, and 13, and it will give us 3, 3, 9. Now we have the cumulative demand for past 3 weeks. Now we need the 3-week average demand. Since they said we use the 3-week moving average for the forecast. So we also need the column for 3-week average demand. Now for week 10, we didn't have the cumulative demand for past 3 weeks, so we won't have the average for week 11 and week 12. But for week 13, we had the cumulative demand for past 3 weeks. So our 3-week average demand will be the 322, which is the cumulative demand for past 3 weeks. We divide by those 3 weeks. This is the 3-week average demand, and it will give us 107.3. We come for week 14, we do the same, and we get 111.7. For 15, it will give us 115, and then week 16 it will give us 113. But remember, they said we need the forecast for the demand of the item. We are given 16 weeks, so at the 16th week, the demand for that item will be 113 units. So our forecast will be 113 units. So that will be our work. So the first method was simple moving average. We looked at that, we got an example. Now we got the second method, which is mean absolute deviation. The mean absolute deviation is the average of absolute values. It is used for calculations of demand variability. The method also provides additional information that is useful in selecting the forecasting model and its parameters. So we are going to look at how the mean absolute deviation works. We have our formula for mean absolute deviation. So for mean absolute deviation, we have our formula. Mean absolute deviation is given by 1 over n, summation from I equal to 1 up to n, then magnitude of error I. Then we are given this example. We have month, we have demand in units, and forecast. That's what we are given. Then we have month 1, month 2, month 3, month 4, and month 5. Then the demand for the first month is 20 and its forecast is 18. Demand for the second month is 30 and for the forecast is 25. The third month we have 10 and 15. Fourth month we have 40 and 15 and 30. Then the fifth month we have 50 and 55. That is the information we are given. They want us to get the mean absolute deviation. How do we get it? From our formula, which is MAD equal to 1 over n, summation from I equal to 1 to n, modulus of EI. Now we have n, which is the number of months, and it is 5, but we don't have our E. How do we get the E? This is the error. Now we create another column for error E. So for the first month, our error will be, first to get the error, we get the demand minus the forecast. So what is our error for the first month? It will be 20 minus 18, which is positive 2. For the second month is 30 minus 25, which is positive 5. For the third month, it will be negative 5. For the fourth month, we have positive 10, and the last month we have negative 5. Now we come and substitute in our formula. So our mean absolute deviation will be 1/5 into, we sum the errors, it will be 2, but since you have this magnitude sign, everything will be positive, even the negatives will turn to positive. So we shall have 2 plus 5 plus 5 plus 10 plus 5, and this will give us 5.4, and this will be our mean absolute deviation. That's what we shall be getting. Now we go the third method of forecasting, which is exponential smoothing. This method is similar to moving average method, except that it does not require a large amount of historical data. This method is particularly used for applications that involve forecasting for a large number of items. Then for exponential smoothing, it has its formula that I will show you below. So the formula for exponential smoothing is ft equaling to ft minus 1 plus alpha into at minus 1 minus ft minus 1. That is our formula for exponential smoothing. Now we need to know, what does ft mean? Ft is the exponential smooth forecasted demand for period t, that is ft. Then ft minus 1 is the exponentially smooth forecasted demand for the previous period, since it is ft minus 1, meaning that period minus 1, the previous period. Then the alpha represents the smoothing constant, which is always given in the question. Then lt minus 1, it is the actual demand for the previous period, since it carries this t minus 1. We have already seen ft minus 1. So we got our example that said, assume alpha is equal to 0.1, that is our alpha 0.1, where the actual demand for forecasted demand for the most recent period are the actual demand, which is 80 minus 1 is 250. Then the forecasted demand is, which is ft minus 1, is 300. Now they want you to get the exponentially smooth forecasted demand, that is ft. They want you to get the ft. How do you get ft? We already saw from our formula that ft is equal to ft minus 1 plus alpha into 80 minus 1 minus ft minus 1. So what is our ft minus 1? It was given as 300. So it will be 300 plus our alpha, the smoothing constant, which is 0.1, into 80 minus 1, the actual demand for the previous period, which is 250, minus 300, and this will give us 295 units. So this will be our exponentially smooth forecasted demand for that period. Okay, thank you for watching, thank you for following. Hope you find this video educative. Thanks so much. Don't forget to subscribe and like our channel.